Namaste, welcome to our guidance classes for Group 1 services examination conducted by TCET. As you know that science and technology is one of the concepts from the 13 areas of the Group 1 syllabi. In science and technology, the basic concepts of physics is very important to understand the other branches of this science and technology. So, as you know that in the last episode we discussed about the motion and the rest. As you know that the motion and rest both are relative words. So, which is you can say as both sides of the same coin. You cannot divide it as which is at rest and which is at motion. Clear? So if you want to understand all these things, then we have to discuss about the basics laws, that is Newton's laws. As the first Newton law explains the concept of moment of inertia. So what is the moment of inertia? Unless and until if the external force acting on it, then only there is a change of position in the body. Otherwise, it will maintain, it will continue as its same position. Okay, now come to the next one is Newton's second law. As Newton's second law says that, as you know that, Newton's first law, in order to move an object needs a force, correct? Generally, a force is a push or pull, maybe push or maybe pull. For example, the front door needs a push before it can open, correct? So, Newton's second law asserts that a force depends on the mass of an object, exerting that force and its acceleration. Quickly pushing a hand forward to open the door will create a much more forcible entrance than if the same person slowed their approach. So, now we will see that means here the force is called simply F is equal to ma. F is equal to ma. Means here simply the rate of ma, you can write it just now, you can write it as m of v minus u by t, or simply mv minus mu by t. mv is a final momentum and mu is the initial momentum. Rate of change of momentum, it is rate of change of momentum is called the force. That's about the force, and Newton's second law explains the force. Clear? Okay. So now we are going to discuss about the force and its application. So as just now I said, F is equal to, as you know that, m of v minus u by t or mv minus mu by t. Clear? Okay. So the units of force is in SI units it is Newton, in CGS units it is Dynes, and the relation between these two, 1 Newton is equal to, simply we call it as 10 to the power 5 Dynes. This is a relation between a Newton and a Dynes. So this is a very important. You can classify the forces as basically as two kinds. One is a weak force, another one is a strong force. Magnetical force is there, gravitational force is there, clear? Electrical force is there. So all these different kinds of forces here. Simply we call it as this one, the force depends on the mass. You can say depends on the mass, clear? So F is equal to ma. Just now I said F is equal to ma. Okay. So depends on the force means here as you know that here F is equal to mg. This is called gravitational force. F is equal to mg is a gravitational force. Clear? And if you want to know, so the force between two celestial bodies, mass of one celestial body is say m1, mass of the another celestial body is m2, means, and the simply the distance between the two celestial bodies as r. Simply F is proportional to m1 m2, F is proportional to r square 1 by r square, and F is proportional to m1 m2 by r square, or F is equal to g m1 m2 by r square. This one is called universal gravitational force. F is called the universal gravitational force and G is called universal gravitational constant. This is a very important. G is called universal gravitational constant. This G value is 6.617 into 10 power minus 27 Newton meter square per kg square. This is the value. Universal gravitational constant here. So, means m1 m2 mass of the two celestial bodies. Clear? So, generally we can calculate this one is, and as you know that here we are using the gravitational force G, that's G is a gravitational force. The value gravitational force is G is equal to, actually G value is 9.8 meter per second square. This one called as acceleration due to gravity. Here G is called acceleration due to gravity. It is maximum at poles and minimum at equator. Okay. So, it is around 9.83 meter per second square at poles and 9.78 meter per second square at the equator. Clear? This gravitation will change with respect to the position nature of the land also. The G will be varies. So, when you compare the G value with earth and moon, when you compare the G value earth and moon here, the acceleration due to gravity is 1/6 of our earth. That's the main reason. Means here if you say G is the acceleration due to gravity at earth, then the acceleration due to gravity on moon, this is GM you will say. The acceleration due to gravity at GM means here, and it is acceleration due to gravity at moon, capital M. So, it is simply GM by 6 means here simply 9.8 by 6 means here approximately it is 138, 1.62 meter per second square on the moon. For that reason, there is no atmosphere on the moon. This is one of the reason. We have to notice all these things here. Clear? Okay. Now, coming to the next one, Newton's third law. Newton's third law means here, so this is a very frequently used. For every action, there is an equal and opposite reaction. That is called Newton's third law. All these projection of rockets works on the Newton's third law. The force don't act in isolation. Each is always accompanied by another force that pushes or pulls in the opposite direction. When pushing a chair across the floor, for example, not only does an exert of force that moves the chair, but the floor exerts another force that is called friction opposing the push. Means if you want to push or pull a chair on a ground, means between the ground and the chair there is some frictional force. So, when you overcome the frictional force, then only the chair can move. Means you have to provide the force more than the frictional force existing between the chair and the ground. That is a very, very important. So, means if you take it as a bullock cart means here, or horse cart means here, if you take it as, so it it push the land, how much force it push the land, the same force equally it push the horse to move forward. Then in this manner this bullock cart or horse carts will move. For example, Newton's third law in action including a car wheels push backward on the ground, making use of the road friction force and moving forward. So, when you apply the acceleration, then there is a frictional force existing between the tires and the road. When it overcomes, then the tires move forward and the car or the vehicle move forward. Even let us take observe the birds. The bird's wings push the air down and back to generate lift and fly forward. This is the principle just there in the bird's flight. Simply what will happen? The bird's wings simply push the air down and back to generate lift and fly forward. Even swimming also. Let us take you are observing a swimming or moving a boat. In swimming, what will happen? Generally, we will push the water with the hands in opposite direction, backward direction, correct? You are moving your hands backward direction. So, then the water push you in forward direction. So, pushing the water backward direction is the action. Pulling you, of course, pushing you in forward direction, that is the opposite action, correct? So, every action there is an equal opposite reaction. So, that is called Newton's third law. Most of the things most of the activities are done by the Newton's third law only. These are the few examples to know about the Newton's third law. Clear? Now coming to the gravity. Most famous as the force that makes things fall down. For fundamentally, gravity is a force of attraction. Not only does it attract things to Earth's surface, but it keeps planets orbiting stars. Gravity is also the reason things have weight. Everything has mass, a measure of the amount of matter in an object, but the force of Earth's gravitational pull is what creates weight. So, you feel, means this is a very important and interesting phenomenon. So, you feel a weight because of gravity. You feel weight because of gravity. That's a very, very important. Any object has a certain weight because of gravity. So, means you feel a zero weight in vacuum. You feel zero weight in vacuum. What is the reason? There is no gravity. Clear? I will give one more example. You are traveling on a lift. Suddenly, the lift was broken. The lift is falling down. Then what will happen? You feel that you are weightless. The reason is the gravity at that time is zero. Then already you know that. So, actually that is V is equal to, or the force F is equal to m of A minus G. Both are in different directions, A minus C. If A becomes A is equal to G, means F of G minus G, that is m of 0, which is 0. Means you feel weightless. In space, you feel weightless. The reason is there is no gravity. You feel weight because of gravity. If there is no gravity, then you feel weightless. Already I said there are so many factors At the pole you have the maximum gravity, and at equator it is a minimum, and where is there some what you call it as different minerals are there, or heavy metals are there, then the gravity also influences. That is about gravity. So, actually a body, you feel a body or you feel having weight because of gravity. So, means generally the weight we will consider as the gravitational force acting on it. That is the reason we will say W is equal to mg. The weight of the body is called mg. Clear? So, that's a very, very important here. So, when you are at vacuum, your weight is 0 because there is no gravity. That is the reason you feel weightless. So, very important thing is, so for example, so we are taking a celestial body as having mass m1 and another celestial body having mass m2, and the distance between these two is r, then F is the force, universal force is directly proportional to m1 m2, and F is proportional to 1 by r square, and F is proportional to m1 m2 by r square, or F is equal to g m1 m2 by r square. Here g is called universal gravitational constant, and this g value is 6.617 into 10 power minus 27 Newton meter square per kg square. So, this value is a very important here. That is called universal gravitational constant. Okay. Then what is the relation between these two? Means when you take it as a body is mg, correct, and here this is a gm, okay, gm m1 m2 gm by r square. Okay, then we can say the relation between gmm, you call it as, say m is the mass of the earth and the small m is mass of the object, then the relation between the gravitational force is mg here. The universal gravitational force is gmm by r square, then you can cancel this and this m, then you will get as g is equal to gm by r square. This is the relation between small g and capital G, means acceleration due to gravity and universal gravitational constant. So, this is the most important thing here, already I said. So, here at poles it is maximum, it is a 9.83 meter per second square, but at equator it will be around 9.78 meter per second square. In general, for our calculation purpose, G will be considered as 9.8 meter per second square. These are the values generally we are using. Clear? Okay. So, means here when you consider this lift moving that, so then with the weight of the body W is equal to m into g plus or minus ca. So, means plus or minus ca means here if the lift is moving upwards, the gravitational force is always downwards, means here acceleration is in upward direction and g will be in downward direction. So, the weight of the body is W is equal to m of g minus a. For example, the lift is moving downwards, means acceleration is moving down, of course in downward direction, gravitational force also in the same direction. then so W is equal to m of g plus a. So you have to remember these things. This is a most important concept. Clear? Okay. So means, and as you know that about the moon and earth, when you consider the moon and earth, the acceleration due to gravity at moon is 1/6 of the acceleration due to gravity when you compare with our earth. So here g of earth is equal to 6 times of g of moon, or g of moon is equal to 1/6 of g of earth. This is a relation between the acceleration due to gravity at earth at moon. For that reason, so there is no atmosphere in the moon. There is no atmosphere. The reason behind is there. Clear? So that's very, very important. And so here we are using, by using this one, we will call it as escaping velocity is and VO, orbital velocity. Escaping velocity, orbital velocity. You are using two words based on this gravitational force. So means escaping velocity is √2gr, and orbital velocity is √gr, and g is the acceleration due to gravity, r is the radius of our earth, and v is the escaping velocity, or VO is the orbital velocity. The relation between escaping velocity and orbital velocity, VE is equal to √2 times of VO. This is a very, very important relation. Escaping velocity and orbital velocity. VE is equal to √2 VO is a very, very important. And the escaping velocity is of at earth is 11.2 kilometers per second. The escaping velocity of on earth is 11.2 kilometers per second. What is escaping velocity? Escaping velocity means so the velocity is required to project a body to escape from the gravitational force of our earth. Okay, that's escaping velocity. Orbital velocity means the velocity required to move in the specified orbital is called the orbital velocity. This is about escaping velocity and orbital velocity. Generally, they will ask about on this one. As you know that this gravitational force and the relation between gravitational force and universal gravitational constant. Clear? Okay. Now we are shifting to the next one, that's called centripetal force. So actually the forces can be considered, of course, we can classify the forces with respect to a center as two kinds. One is called centripetal force, a second one is called centrifugal force. Centripetal force and centrifugal force means the force acting towards the center, that's called centripetal force. The force away from the center is called centrifugal force. So means here centripetal force and centrifugal force, I will give a small example. Means the washing machines works on centrifugal force, because means so the heavy dust particles will drive away from the center and driven towards the drainage, and those dust particles will push to the drainage, and that will be sent to it. That's called centrifugal force. And centrifugal force means it acts towards the center. So means here the waves in sea, because of centrifugal force, the waves will comes upwards and fall downwards. The low speed limits posted for on and off ramps are there for this reason. The centrifugal force. When something accelerates along a circular path, the centrifugal force keeps it going in the circle. For curved exit ramps, The speed limits have been specially calculated to ensure that the centripetal force keeps the car on its path. So, that is are you understand that is a centripetal and centrifugal force. The force acting towards is simply we call it as F is equal to, we will say F is equal to mv square by r. F is equal to mv square by r. Centripetal force or centrifugal force, these two can be calculated by using this formula. Clear? Now, we are going to discuss about centripetal and centrifugal forces and all. So, I am using the word force. Now, come to the next one, that is work and energy. Work and energy means here the work happens whenever a force moves something. Whenever someone does work on another object like moving a chair across the floor, they also transfer energy into the object. In this case, the person moving the chair gives it kinetic energy and the energy of the motion. So, this is very, very important. Basically, we have two kinds of energies. One is called kinetic energy and potential energy. Clear? So, kinetic energy and potential energy. So, now what is kinetic energy, what is a potential energy, we will see it. Generally, kinetic energy Ke is called half me square and the potential energy P is equal to also of mgh. This is called kinetic energy and potential energy. Now, from this you can understand, from this equations you can understand from formulas. When the body is in moving, it has a kinetic energy. When the body is at rest, it has potential energy. When the waterfalls means here waterfalls, so here when you observe the waterfalls, so there what happens, the potential energy is converted into kinetic energy. Potential energy is converted into kinetic energy. That is a relation between this here. Clear? When the body is moving in motion, it has a kinetic energy. When the body is rest, it has a potential energy. So, the body is at h meters height, that is it has a potential energy. When the body is moving, it has a kinetic energy. So, when the body is moving, it has a kinetic energy. When the body is at rest, we have. So, this part of a law of conservation energy, energy cannot be created or destroyed. That is called is a law of conservation of energy. There is no possibility to create or destroy the energy. We can convert one kind of energy to another kind of energy, but there is no creation or no destruction. This is called a conservation of energy. This concept helps explain how fuel and engine works and why car owners need to buy gasoline or charge their vehicles. When a driver starts up their car, the car does not create a kinetic energy to move. Instead, the chemical or potential energy in the fuel of the car combusts in the engine to generate motion, converting potential energy into kinetic energy. This is the most important. This is the most important here. What will happen? The petrol means here the fuel petrol or diesel or gasoline, whatever it may be, the fuel combusts the engine to generate the motion. What will happen here? It converts potential energy to kinetic energy, then the car will move it. This is a very important scientific phenomena you have to understand. So, here conservation of energy are using, that is called simply E is equal to mc square. E is equal to mc square, this is called what you call it as mass and energy equivalence equation. Einstein equation we call it as simply a very familiar, this is a conservation of energy. E equal to mc square, where m is the mass, c is the speed of light, and E is the energy generated. Conservation of energy means there is no possibility of energy creation or destruction, but you can transfer one kind of energy to another kind of energy. That is a transformation. If you take it as a bulb, so means the bulb is an instrument which convert electrical energy into light energy and heat energy, correct? So, that is one means, for example, if you take it as a generator. So, generator means simply the generator is converts means a chemical energy or hydroelectrical energy into mechanical energy. Let us take fan. Electrical energy is converted into mechanical energy, correct? A cell, that is a chemical energy, is converted into electrical energy. Even gas stove, so means here chemical energy is converted into heat energy. Means now observe all these things here. One kind of energy is converted into another kind of energy, just a transformation of one kind of energy to another kind of energy, but there is no creation or destruction of the energy. That is called conservation of energy. So, we will discuss some more basic concepts in the next sessions. Until Namaste.